Hello viewers, in today's class we are going to discuss yet another important concept from definite integrals, right? And here we have to evaluate these two important integrals, right? So the first one is from 0 to 1 x cube log x square, right? The second one is 0 to 1 x raised to 4 log x raised to 3, right? Here we are not going to solve these two problems by the usual method of making use of reduction formulas, right? So what we will do here, we'll directly write the values of these two integrals by making use of a direct result, right? So let us first see the general integral, right? And then we'll compare these two integrals with that general integral. So now let us consider this integral, that is 0 to 1, and we have x raised to m and log of x raised to n, right? So here we'll consider this one. So we see that these two integrals are quite similar to this one. So here the limits are 0 to 1, 0 to 1. Here also we have 0 to 1, and here we have x raised to 3, and here we have in general x raised to m, and here we have log x raised to 2, and here in general we have log x raised to n, right? And here these two numbers m and n, they belongs to the set of natural numbers, right? So what we will do, let us first write the result for this integral. So the direct result is minus 1 raised to n, and we have factorial n, and in the denominator we have m plus 1 raised to n plus 1, right? So this is the result for this integral. So now we'll use this result to solve these two integrals. So now let us consider the first one. So if we compare this integral with this one, then the value of m is 3 and n is 2, right? So now applying this result, we have minus 1 raised to n is 2, then n factorial, this is 2 factorial, and divided by m plus 1, so we have 3 plus 1 raised to n plus 1. So here we have 2 plus 1. So minus 1 square is 1, and 2 factorial is simply 2. This is 4 raised to 3, right? So this is 2 over 64, that is equal to 1 over 32. So now let us consider this integral. So now comparing this integral with this one, the value of m is 4 and the value of n is 3, right? So the value of this integral can be written with the help of this result. So we have minus 1 raised to n is 3, and then we have 3 factorial here, and then in the denominator we have m plus 1, so we have 4 plus 1 raised to n plus 1, and n is 3, so here we have 3 plus 1. So minus 1 raised to 3 is minus 1, 3 factorial is 6, and this is 5 raised to 4, right? So this is minus 6 over 625, right? So 5 raised to 4 is 625. Now let us consider a third problem. So here we have 0 to 1 x log x dx, right? So this is a very well-known problem, and we can solve this integral by making use of integration by parts, right? So we can also verify the result by making use of integration by parts. So here we'll solve this integral with the help of this formula, right? So if we compare this integral with this one, then the value of m is 1 and the value of n is also equal to 1, because here we have x raised to 1 and log x raised to 1. So n and m both are equal, right? So now substituting m is equal to 1 and n is equal to 1 in this result, we have minus 1 raised to 1, then we have 1 factorial, then we have 1 plus 1 raised to 1 plus 1, right? So this is minus 1 raised to 1 is minus 1, 1 factorial is 1, and this is 2 raised to 2, so this is minus 1 raised to 4, right? So viewers, this is how by making use of these type of quick results, we can arrive at the values of these type of integrals.